Hello class, good afternoon. Our topic for today is properties of sound and its effect. When you say sound, it is produced by vibrating objects. So, let us explain some of its properties. So, the properties of sound are speed, intensity, and frequency. Let's start with speed. Speed is the ability of any material to transmit sound depends on a property called elasticity. The more elastic the medium, the faster the sound travels. Elastic solids are very good transmitters of sounds. Since their particles are compressed, they can easily go back to their original positions and they can easily spread out again. Rubber, plastic, and cloth are poor transmitter of sounds. Liquids are better conductors of sound than gases since the particles in liquid are closer to each other than the particles in gas, because you know that the particles of gas are spread spread out while the particles of liquid are more compact. The sound waves are transmitted easier in liquids. However, the particles in solids are closer than liquids. That's why the sound can easily transmitted in solid. So, gas, liquid, then solid. So, this table shows the speed of sounds in various media. So, in air, 331 with 0 degrees Celsius, that is the slowest. In liquid, the slowest is fresh water, which is 1490 meter per second. And for solid, is the slowest is rubber, which is 54 meter per second. And the fastest is the steel, which is 5200 meter per second. Now let's proceed to intensity and loudness. When you say intensity, it is the amount of energy that a wave carries per second through a given area. The intensity of sound describes its loudness at a particular distance from the source of the sound. Sound intensity depends on both waves' amplitude and the distance from the sound source. It means that if you are nearer to the sound source, the intensity is higher. If you are far from the sound source, the intensity is lower. The greater the amplitude of the sound waves, the louder the sound. So, higher the amplitude, higher the sound. Lower the amplitude, it means lower sound. Loudness also depends on the distance from the source of sound waves. So, sound intensity levels are measured in units called decibels. So, I will repeat. For the sound intensity, we use decibels. The decibel is a unit that compares the intensity of different sounds. So, okay, 50 decibels, it means, okay, low intensity. 180 decibels or 1 to 70 decibels, high intensity. So this table shows the loudness of sound. So human hearing 0, rustling leaves 10 decibels, and the highest is space shuttle engine, which is 200 decibels. And in this loudness, okay, you need to use noise cancellation technology. So let's proceed to frequency. In frequency, we use the unit Hz or hertz. Okay. Frequency is the number of vibrations of sound waves per second. The human ear is unable to detect sound waves of all frequencies. It can only respond to the frequencies ranging from 20 to 20,000 hertz. This is called the audible range. So lower than 20 hertz, it means that human cannot able to detect these frequencies. Sound waves of frequencies above 20 hertz are called ultrasonic. So a while ago, audible 20 to 20,000. 20,000 above is ultrasonic waves. Sounds below um 20 hertz is what we call infrasound or the lower frequency. Any sound with a frequency below the range of human hearing is known as infrasound, and any sound with a frequency below human hearing range is also known as ultrasound. Any sound, okay, this one is with a frequency higher than human hearing. So this must be above human hearing range known as ultrasound, not below. So here are the frequency of different animals or humans. 40 hertz to 46,000 hertz for dogs, 70 hertz to 150,000 hertz for dolphins, 6 hertz to 12,000 hertz is elephant, and 20 hertz to 20,000 hertz is the saxophone. So let's proceed to pitch. Pitch is being referred to as the number of sound waves we are sending out. This means that pitch depends on the frequency of sound vibration. So, gaano kadalas yung sound vibration? The higher the frequency is, the higher the pitch. It means that so if the frequency is higher, the pitch is higher as well. If the frequency is low, the pitch is low. Pitch depends on four factors: the kinds of material, the length of the string, the thickness of the string, and the thickness of how it is being stretched. So it means that if you have, okay, thick string, it means it is lower in pitch. If you have thin string, then the pitch that will produce is higher compared to the thick string. So one more is, the more tight the string, then it will produce higher pitch and higher frequency. So let's proceed to music and noise. So we say music if it is have regular pattern of notes, while noise has irregular pattern of notes. Okay, so the sound vibrations produced by noise show irregular waves that create unpleasant sensation to ear. So it's not nice to hear for noise. While music produces sound waves of regular and uniform pattern, this creates a pleasant sensation to the ear because there is a rhythm and harmony. I will repeat. Music is has irregular or regular notes. That's why it is pleasant to hear, while noise produces irregular and erratic waves and it is unpleasant to hear. So what can individual do to avoid risk of getting deaf because of too much loudness? Okay. All workers in noise environment can benefit from ear protectors such as plugs or headphone like muffler. Ear protectors can reduce noise level by 35 decibels. That's why for those works that produce high decibels, it is important for the workers to use ear protectors.